Welcome back, class, and today we're going to start the next review, which is on factoring polynomials. So last time we talked about polynomials in general and how to expand and use the distributive property to simplify polynomial expressions and multiplying polynomials, dividing polynomials, and such. But today we're going to talk about factoring, which is also using the distributive property, but going the opposite direction. Okay, so the process of finding polynomials whose product equals the given polynomial is called factoring. And this is the same thing that we do when we factor numbers, right? If we take a number, let's say 12, and we want to find two factors of 12 that multiply to equal 12, that's factoring, right? So what we're going to do is we're going to treat polynomials, because polynomials are real numbers. We just don't know what they are, and we're going to factor them the same way. We're going to look for two smaller polynomials, two other polynomials, that when we multiply them will give us the polynomial we started with. Okay? So in this example here, we have 4x plus 12, and we can find a common factor here, right? 4, and is 4 also a factor? Yes. So we can take the factor of 12 as 4 and 3. So then what we can do is we could take out the factor by using the distributive property, and we can rewrite this as 4 times the quantity x plus 3. Okay? And so both 4 and the quantity x plus 3 are factors of the polynomial 4x plus 12. Okay? So this is what we considered factored form. Okay? Okay, so now a polynomial with variable terms that cannot be written as a product of two factors, and it should not be a surprise that we call that a prime polynomial, right? Just like if we have a prime number like 3, 3 cannot be split up into two factors other than 1 and 3. Okay, so we call that a prime number. So prime polynomials behave this very similarly. Okay. A polynomial is factored completely when it is written as a product of prime polynomials. Okay, so the first thing we're going to talk about is factoring out the greatest common factor, because that is the first step in factoring any polynomial. Is you want to find the greatest common factor if one exists. Okay, so what we do is we look at the terms of the polynomial and we look for the biggest number that can divide that term. Okay, so and that is going to be the greatest factor for that term, and we want to find one that's common to all of the terms, and so that is the greatest common factor. Okay, the biggest factor that we could take out of each one of these products. Okay, so in this case here we find that the biggest coefficient that will divide all of these numbers is 3. So the greatest common factor of the coefficients is 3. So we're going to pull a 3 out. The greatest factor that we can pull out of the x's is going to be the smallest power, and in this case is going to be x. And then the greatest common factor of the y's is going to be the smallest exponent of the y's, which is x cubed. So now in this case here, oh, I'm sorry, I misspoke. There's no x here. So the greatest common factor for the x's is going to be x to the 0, which is 1. So the greatest common factor is going to be 3y cubed. So we're going to pull out a 3y cubed, and we're going to write this, each term, as a product of 3y cubed times what's left over. Okay, so in this case, it'll be 2x squared is going to be left over. Here, it's going to be 3x y squared, or excuse me, 3xy is going to be left over. Okay, and then here it's going to be what? It's going to be 6y to the second. Okay, and so now what we do is, now that we've got it written in as a common factor written out here as factors, now we can factor out using the distributive property, and we can write it as 3y cubed times the quantity of this trinomial, and we're done. Okay, because there's nothing else we can do. Okay, so now in this example here, we're going to do some same thing. Oh, let me pull it up so we don't see the solutions, and maybe we can work out the first one at a time. Okay. Okay, so now in this first example here, let's do A. Okay, so let's look for the greatest common factor in each term. So now in the coefficients, there's no greatest common factor other than 1, so we can't pull out anything there. But if you look at the y's, we could definitely pull out a y squared from each one. And so if we rewrite this as not y squared times 9y cubed, and then we'll write this term as just y squared times 1, then we could see that we could pull out a y squared, and we end up with the quantity left over for this one right here. Okay? So we could pull out the y squared, and we get y squared times the quantity 9y cubed plus 1. Okay? Now don't forget this. This is important that if this is a common factor, we always leave a 1 behind, not a 0. Some students will put a 0 here, but remember, we're writing as a product of two factors, right? Y squared times 1. Okay, because again, how do we get back to the original expression, right? Okay, now the next one, we're going to do the same thing. So we look at the coefficients. What's the biggest number that we can divide all three numbers by? Well, in this case, it's going to be 2. Okay, so the biggest number we're going to be able to factor out is 2, so we're going to factor out a 2 from each one of these. And then we're going to look at the x's. What's the smallest exponent of x that we can factor out? Again, there's 0 here, so we can't factor out any x's. What about t's? Well, we can factor out a t, so we can factor out a 2 and a t from each one. And that will be the way we're going to rewrite each term. Okay, so we pull out a 2t, and that leaves us a 3x squared from this one, leaves us a 4x from this one, and a negative 6 from this one. Now, if you want to make sure that you got the correct answer, always multiply out and see if you get back to the original polynomial. So in this case here, we would just use the distributive property and distribute the 2t to each term and simplify. And sure enough, when we do that, we get back to the original problem. So it checks. Okay, now let's do this one. Okay, now notice that we've got a common factor in each one of these of x plus 1, but there's different exponents. So again, we're going to choose the one with the smallest exponent. So we're going to factor out 1 m plus 1, and then also the coefficients, we have a common factor of 7, because the largest number that will divide all three is 7. So we're going to factor out an m times m plus 1. And again, it might be helpful to do the same thing that we did up here, rewrite each term as a product of two factors. Okay, so now we factor out the 7, and we get this plus this times this. Okay, now we can expand this one out, and we get this. So now we're going to simplify things, right? We don't want to leave it in this term. This is not simplified. So let's square this, expand this out, and then we're going to use the distributive property, and we're going to combine like terms. Okay, and we get this. And so we're going to combine like terms. This is going to cancel with this one. This is going to combine with these. This is going to give a negative 5. And this is going to give us a plus 2. So this is going to give us negative 3. And we end up with 2m squared minus 3. And there it is completely in factored form. So you may want to try these examples here, these exercises, and see if you could do them on your own. Okay, so now, as in example 1a, the 1 is essential. So again, back to what I said, okay? So this is not the same as this, okay? So because we dropped a 1 here, okay? So again, remember, when you factor out y squared, you're not leaving behind 0, you're leaving behind 1, okay? The number 1. So again, you can always check this by multiplying. If you multiply this, you don't get back to this. Okay? Okay, factor by grouping. So sometimes you'll have a polynomial that's 4 terms, and you may be able to factor by grouping them into two groups of 2 terms. Okay, so for example, if you look at this one here, we can group the first 2 terms because they have a common factor of a, and the second 2 terms have a common factor of 6. So we can group these 2 together, and factor them. Okay, so now what happens when we factor them? Now this, again, what happens here is when we factor out the a, we get x plus y. When we factor out the 6, we also get it x plus y. So now look what happens. We get another common factor. And now we can take the factoring again. Okay, so we factored once to get these 2. Now we're going to factor because now we have another common factor. This time it's x plus y. Now we can factor out the x plus y, and we're left over with a plus 6. And so we get this final factored form. And so this is what we call factor by grouping. We group the terms together like so, and then we factor the greatest common factor, and then if it works, then we notice that we have another greatest common factor, and we factor again. Okay. Now, it doesn't always work, but if you have 4 terms, it's always a good place to start. Okay. Okay, so here we're going to factor by grouping. Okay, so notice that these 2 terms have m in common, and these 2 terms have a common factor of 3. Okay, now, what if we grouped this term with this term because they have p's in common? We could do that. And then these 2 terms also have a greatest common factor of 7 involved. Okay, so in this case, you can group these 2 together, or you could group the first term and the third term together. Okay, but in this case, let's just stick with the m's. So we group these 2 together, and now we notice we have a common factor of m. So we factor out the m here, and leaves us p squared plus 7. And here we're going to factor out a 3, and we get 3 times p squared plus 7 again. And notice that we have a common factor again. Now we can factor out the p squared plus 7 factor, and we get p squared plus 7 times the quantity m plus 3. Okay, we could do the same thing here. Okay, notice that these 2 terms have a z in common, and these 2 terms have a y in common. Okay, or notice that these 2 terms have a's in common, but these 2 terms here have a 2 in common. Okay, so you could split it up either way, okay, and do the factor by grouping. And again, don't forget your check. You can always FOIL and to make sure you get back to what you started with, okay? And again, it's good practice to check these at least until you're confident that you're doing it correctly. Okay. Okay, now for this one here, they're going to match up the 2's together and the a's together, the ones with the a's. So again, this is going to have a common factor of 2. Okay, and these are going to have a common factor of a. Or in this case, they're going to factor out a negative a. Okay. Why do they factor out a negative a? Well, because if you factor out the 2 here, you get y squared minus z. But if you factor out the a, you get a negative y squared plus z. So if we want to get these to be the same, we've got to factor out a negative a. And so this becomes a minus a out here, and we get the same term, the same factor. So now we can factor out another common factor of y squared minus z, and then we get our final answer of y squared minus z times the quantity 2 minus a. And again, you could always factor out to verify that you did get the correct answer. Okay, and then finally with this one here, we've got 4x cubed and 2x squared. And then here, we've got 2x minus 1. Okay, so here we got x's here. So let's group these 2 together and group these 2 together. If we factor out the greatest common factor, which in this case is going to be 2x squared. So we've got the largest number we can factor out is 2, and the largest variable we can factor out is x squared. So we can factor out a 2x squared, which leaves us a 2x plus 1. And notice that we have a minus 2x minus 1. So we can factor out a negative 1 here, and we get the same factor in both terms. So this becomes a minus 1. Now we're going to factor out 2x plus 1, and we get 2x plus 1, and then times what's left over, which is 2x squared minus 1. And so again, practice these two exercises to just make sure that you know how to do them. If you get stuck, again, bring those questions to class. If you don't understand any of these examples or you get tripped up, again, make sure you do these examples on your own. Write them out on a piece of paper and see if you could do it without looking at the solution. Okay? If you have any questions or you get stuck or you're not sure understanding why they're able to do what they do, bring it to class. Email me. We could always work it out in class together and go over these problems. Okay? Especially the examples here. Okay, factoring trinomials. Okay, so here we go. We're going to add more tools to the toolbox. Okay, so if multiplication helps us to go from factored form to expanded polynomial form, right? Or we could use factoring to go from the expanded form to factored form. Okay, and both involves the distributive property. Okay. So one strategy when factoring trinomials is to use the FOIL method in reverse, right? This strategy requires trial and error. I'm not a big fan of trial and error unless you're good at it, okay, which most people aren't. With simple trinomials, it's easy to do, but with more complicated ones, it's not so easy to do. Okay, so again, I'm not a big fan of trial and error. And trying to figure out what coefficients go where. I mean, if you like to problem solve like that and you like to solve the puzzle like that, I mean, I love problem solving, but again, if there's other tools we can use, I'd rather use those. Okay, again, so here, if we use the trinomial here, well, we're going to figure out how we're going to do this. Okay, so let's use A as an example. Okay, so we know that it has to be in this form if we use the FOIL method, right? So if we start with this form, it has to be, because we have to have a y in the first, right? And we have a constant in the last. So it has to be, remember, there has to be a y because the first term is always the first times last. Or excuse me, the first terms, right? So the first term has to have a y in it in both first terms. Okay, the last term has to be a constant because this is the last term's multiplied. There's no variable, so the last term has to be a constant. So we have to have something like this, ay plus b times the quantity cy plus d. Now if we FOIL this out, we know that a times c must be equal to 4 and b times d must be equal to 6. Okay? So the positive factors of 4 are 4 and 1, or 2 and 2. Those are the only positive factors we can get. Okay, so we got to figure out what two of those factors. Okay, now because the middle term, hold on a second. So these are the factors. So we know that the beginning terms a and c must be one of these factors. We don't know which one though. We're going to figure it out. Okay, now because the middle term has a negative coefficient, we consider only negative factors of 6. Okay? Negative factors of 6. Okay, so the possibilities are -2 and -3, or -1 and -6. Why? Because this is positive. So the only way for this to be positive is if they're both negative or both factors are positive. But because the middle term is negative, we know that they both have to be negative terms. So the two factors of 6 that we're going to consider is -2, -3, or -1 and -6. So we got to figure out which combinations of these factors here and these factors over here that will give us the middle term. Okay? Well, how do we get the middle term? Well, it's going to be what? B times C plus A times D, right? So this is where the trial and error comes in. So we just try. So we try 2 and 2 here, and -1 and -6 here. Didn't work. We got a -14. We need to get a -11. Okay, let's try -2. Let's try 2 and -2, right? And 2 and -3. Oh, nope, didn't work. Okay, now let's try 1 and -2. Okay, so now we're going to switch these. So we tried switching these, the second terms. So now let's try these, and we kept these the same. Now let's try these two. Let's try a 1 and a -2, and a 4 and a -3, and that one works. Okay, and thus we know that these are the answers. So the factored form is this. Okay, we can always check by using the FOIL method. Oops. And lo and behold, it checks. Okay, because we got back to the original polynomial. Okay. Now, again, we could try various possibilities of factoring this one. So we look at the positive factors of 6, and we look at the factors of 5 that will give us a -5. Okay. So the factors of 6, again, are going to be 2 and 3 and 1 and 6. The factors of -5 have only -1 and 5 or -5 and 1. Okay. And now we're going to try these factors and see which one gives us the correct answer. So let's try these two. Let's try 2 and -5 and 3 and 1. Okay, so we're going to use 2 and 3 for the first terms, and we're going to use -5 and 1 for the second terms, and it doesn't work. So now let's use 3 and 2. So now we're switching these. 3 and 2 and -5 and 1. And so that one does work. Okay? So trial and error by just using the FOIL method will work. But again, it's tedious. It can be tedious, and it can take a longer time to solve these than necessary. Okay, but it does use the concepts of the distribution and FOIL method of why it works. Okay, it works because it's based on the distributive property. Okay. Okay, so again, you could do the same thing here. Okay, so I'll leave these for you to do on your own. Okay, and just make sure you review. And then, of course, you could use these examples, these exercises to practice. Okay, but again, the method is the same. Okay, you've got to find 2 factors of the first term, 2 factors of the last term that will add, when you do the FOIL method, to the middle term. Okay? So you got to find the combinations of those that will give us the middle term when you FOIL out. Okay? Okay, now let's look at perfect square trinomials. Now we saw this before in the last section. We know that there are certain forms of trinomials that will factor easily. So again, all we're going to use is the fact that x plus y quantity squared will always have the form of this, where we have x squared as the first term, y squared as the last term, and then the middle term is the product of the 2 terms, then doubled. Okay? So this is always the case for perfect square trinomials. Similarly, with the x minus y squared will always give us something like this, same as this, except this is a minus sign. Okay? So notice that this is a perfect square, and this is a perfect square. This is 4p, and this is 5q. Now, if we multiply those two together, 4p and 5q, we get 20pq. Notice that this middle term is double that product. So this is going to be a perfect square. And since this is a negative, it's going to be a difference. So it's going to be 4p minus 5q quantity squared. And that's what we get. Okay, so again, notice this is a square, this is a perfect square, and if we multiply those together and double it, we get the middle term. Okay, and thus we know this is the factored form. And again, if you factor it out, you can get the same thing. Okay, so make sure that the middle term of the trinomial being factored, negative 40pq here, is twice the product of the two terms of the binomial 4p minus 5q. And so it is. Okay, and then again, you can always check by using the FOIL method or using the fact that you know the form. Okay, so you can multiply out and find out what it is. Okay, now here, look at this. Now we notice that, again, this is a perfect square. This is going to be 6, and this is going to be xy. So this is 6xy quantity squared. This is also a perfect square of 7. Now if we take 7 times 6xy, what do you get? Well, 6 times 7 is 42xy. So you get 42xy. Well, this is double that. And so we know that this is the factored form. Okay. Again, try these exercises for practice. Now, let's factor binomials. Now, factoring binomials, again, we're going to have different forms. Notice that this is a difference of two squares. We already know this one. We've seen this one in the last section. So we know that a difference of two squares is always factored into x plus y, x minus y. So x squared minus y squared will always have this form in factored form. Okay. Now, a difference of two cubes has another form. Okay. If we have a difference of two cubes, it's going to be x minus y times this form, which is x squared plus xy plus y squared. So it's similar to the other method that we just talked about, but there's no 2 here. So it's just xy. So all you're going to do is take the x and the y and multiply them together. So if it's a difference of 2 cubes, this is going to be x minus y, and then you're going to have x squared plus xy plus y squared. If it's a sum of 2 cubes, then this is going to be positive, and then this becomes negative, but everything else is the same. Okay, again, you're going to want to know these and memorize them. Again, just it's going to help you in the future as far as other sections in this course. Okay. Now, caution. This is not the same as this. Okay, you cannot pull the 2 out and factor the 2 as an exponent. That does not work. Again, you can show this by just foiling this. If you foil this, you don't get this. You get x squared plus y squared, but you're missing a middle term. This gives you a 2xy. Remember, this is a perfect square. So you always get 2xy in the middle in this case. Okay? Okay, so now let's factor each of these polynomials. Okay, so look at here. This is a square, this is a perfect square, and this is a perfect square, so we have a difference of squares. So the answer is going to be 2m plus 3 times the quantity 2m minus 3. And that's it. Okay. So as soon as you notice it's a difference of two squares, you know what to do. Okay. Now let's look at this one. Now, are these a difference of two squares? Yes. What's 256? What's 256? I believe that's 16 squared is 256. And 625 is 25 squared. Okay? And this is k squared. This is k squared quantity squared. This is m squared quantity squared. So these are both two perfect squares. This is going to be 16k squared quantity squared. This is 25m squared quantity squared. So now we can use that to write it as a difference of two squares. And lo and behold, I was correct. And now I can use that to factor it into this factored form. Notice this is now my quote-unquote x variable. This is my y. So this is x squared minus y squared. So it's going to be x plus y times the quantity x minus y. Okay? Just like we did up here. Right? As long as you know what your x and y are, you can factor it in here. Okay. And of course, you can always check by multiplying and seeing if you get back to the original, and you do. Okay. Now, C. Okay, now this is a square because it's the whole thing's quantity squared, and this is a perfect square. So again, you have a difference of two squares. Your x in this case is a plus 2b. Your y is going to be 2c. And now you know what to do. You just use the form. Okay? So it's going to be this plus this times this times this. And this is your factored form. Now we're going to simplify. This becomes a plus 2b plus 2c. So we can drop the parentheses on the inside. And over here we could drop the parentheses and it becomes this. So this becomes our final answer. Okay, so please don't leave it in this form. Even though you've got it factored correctly, you can simplify further by dropping the inside parentheses and changing these to parentheses. So this becomes your final answer. And then you can also check by, again, multiplying using the distributive property. Now D, look at this. Here we have x squared minus 6x plus 9 minus y to the 4. Okay, so think about this. Okay, here we can separate this off because here we got minus y to the 4th. Now, if this is a perfect square, we've got a difference of two squares. Well, how do we know if this is a perfect square? Well, let's look. This is a square, and this is a perfect square. So we get 3 squared and x squared here. Can we get the middle term if we take the product of those two and double it? Well, x times 3 is 3x, times 2 is 6x. And we do. We get a minus 6x. And since this is minus, this is going to be a perfect square of the form x minus 3 quantity square. And now we know we have a perfect difference of two squares. And so now we can rewrite this in factored form because it's going to be x minus 3 minus 4 squared. Okay, because here's a square, here's our perfect square. So it's going to be x minus 3 plus y squared times the quantity x minus 3 minus y squared. And now what we can do is we can simplify this by dropping the parentheses, and we get this final answer in factored form. And then also, likewise, we can do the same thing for this one. Okay, so again, this is a perfect square. Now notice that there's a y here and there's two x's. So what we're going to do is we're going to separate the y out and we're going to keep this here. Okay, now since this is a negative, we're going to factor out a -1 from this whole thing. So that means this is going to become a positive x squared minus 6x plus 9. Okay, so now we got y squared minus this whole thing. Don't forget to factor out. If we're trying to get a difference of two squares, we want to factor out the negative and make this a subtraction. Okay, so this is the correct way of doing it. Okay, now is this a perfect square? Well, yes it is. This is 3, this is a 3 squared, this is x, so if we take those products of 3x and double it, we get 6x again. So this is the same thing that we had before, So again, we're going to get the quantity x minus 3 quantity squared. Okay, so now we've got difference of two squares again, so now we can use our form, and we're going to get y minus x minus 3 times the quantity y plus x minus 3. Now we're going to simplify this, but before we drop the parentheses here, it's a subtraction, so we got to distribute the negative sign. So this is going to be negative x plus 3. So now this becomes this, and of course this is a plus, so we can just drop the parentheses here, and we get the final answer as this. And again, you can check by using multiplication here. Okay, you could try this practice using these exercises. And next, let's talk about factoring sums and or differences of cubes. Okay, so here we have two cubes, the sum of two cubes. So what we're going to do is, since this is a plus, we're going to have x plus, what's this cube? This is 3 cubed. So we're going to have x plus 3. So our a, if you will, is x, and our b is 3. So this is going to be a plus b times the quantity a squared minus ab plus b squared. Okay, remember the forms. And so if we use that to our advantage, this is what we get. So this sum of two cubes, which you can see here, becomes this. Okay, so notice x plus 3, and then we get x squared minus 3 times x plus 3 squared. Same thing we can do here. So this is a cube. This is a cube, obviously. This is also a cube. This is 16, no, this is 4 cubed. So this is going to be 4n quantity cubed. Okay. So again, we have a difference of two cubes. So that means the form is going to be a minus b quantity times a squared plus ab plus b squared. And again, all we have to do is know our a and our b. So a is m, b is 4n, and so it becomes a minus b, right? A minus b times the quantity a squared times ab. There's m times, right? ab, and then b squared. And so again, just make sure you have the minuses and pluses in the right order. Okay, and then you simplify. And this is the final answer. And then for the last one, what do we have here? Well, we've got a cube. How do we see this as a cube? Well, this is going to be 2 cubed. How can we write q to the 6th power as a cube? Well, remember the power rule. We can write this as q squared raised to the 3rd power. Okay. Likewise, this is going to be 5 cubed. Okay. And this is going to be, again, how can we use the power rule to rewrite p to the 9th power as a cube of some power, right? So it's going to be p cubed raised to the cubed power. Okay. Once we see what our a and b are, then it becomes straightforward. So here it is. So we can rewrite this as this, okay, and then use the form. And we end up with this. And then all we have to do is simplify. And once we simplify, we get our final answer. And we're done. So again, practice using these exercises. And then if you have any questions, email me, let me know, and we can work them out in class, or you can just let me know at the beginning of class. Okay, now, factor by substitution. This one tends to give students trouble. Okay, but all we are doing is we're going to substitute in to make the expression, the polynomial, look simpler. And then what we're going to do is we're going to deal with the simpler polynomial. And then once we factor the simpler polynomial, then we're going to back substitute in what we substituted for back to the original variable. Okay, so what we're going to do is we look at this polynomial here, right? And we see that we have this common term here, but this is squared and this is not. So it looks like it's a polynomial in this variable, right? So what if we replace this 2a minus 1 with a different variable temporarily? Let's say u, okay? What is this going to look like? Well, it's going to look like a new polynomial in u. So that's what we're going to do. So what we do is we take this here and we substitute in for u. So instead of 2a minus 1, we're going to replace that with u. So we get 10u squared minus 19u minus 15. Okay? Now, can this new polynomial be factored? And the answer is yes, it can. Okay? It factors into these two factors. And again, you could use trial by error to do that. I'm going to show you another method shortly to factor these, but factor trinomials like this. But again, this factors into 5u plus 3 times the quantity 2u minus 5. Okay. Now what we're going to do, now that we factored this, now we're going to substitute back for what we did for u. So we're going to put back in 2a minus 1. So now we're going to replace this. Now that it's factored, we're going to put in the 2a minus 1. So we get 5 times this plus 3 times the quantity, 2 times this minus 5. And now we're going to simplify inside the parentheses. And so this becomes this times this. Okay? Now, we're going to simplify this part into negative 7. So this becomes 4a minus 7. And this becomes 10a minus 2. And we get this. Now, what we can do is we can factor out a common factor here of 2. And we get 2 times the quantity 5a minus 1 times 4a minus 7. And we're done. Okay. Now, it would be much more difficult to factor it starting here. But using a u substitution or a substitution of some kind made it very straightforward and a lot easier. Yeah, you had to do a few more steps, but again, much easier than trying to factor this without using a u substitution. Okay, now, what about b? What about this? Well, we have a sum of two cubes, right? Now, we could use the form, and if we realize that, hey, this is our cube here, and this is 2 cubed, so we could use this as our x and 2 as our y and use the form. We could do that. We did that before. But let's use a u substitution to make it a little bit easier to deal with. So let's let 2a minus 1 be u. So now it looks definitely like a sum of two cubes. Now we can use the form that we know to write it as u plus 2 times the quantity u squared minus 2u plus 4. Now that we've got it factored, now we can back substitute and put in 2a minus 1 again. So we're going to substitute in 2a minus 1, and now we're going to go ahead and simplify it. And so we get 2a plus 1, and this simplifies to 4a squared minus 4a plus 1 minus 4a plus 2 plus 4. And now we're going to simplify it even further by adding or combining like terms. And this gives us our final answer. Okay, now what about this one? Okay. Here we've got a z to the fourth z squared. It'd be nice if we could put this into a quadratic where we have a degree 2, right? Because we've been dealing with those. Well, what if we let u equal z squared? This term right here. Well, that means this would be 6u squared minus 13u minus 5, and voila. We can then see if we can factor it. Okay? And once we factor it, now we can back substitute in for u again. And we just replace the u with the z squared. Okay? And at this point here, we're done. We can't really do any more to simplify this expression. And our final answer is 2z squared minus 5 times the quantity 3z squared plus 1. Okay, go ahead and try these exercises for practice. And again, if you get stuck, let me know. And that is the end of this video. Again, if you get stuck on anything or if there's something you're not understanding, feel free to email me. But better yet, bring those questions to class and ask me. Or you can email me those questions and I can go over them in class. If you get stuck on a problem, or again, make sure you try these examples on your own. See if you can get them without looking at the solution. If you get stuck or you're not understanding how they did something, feel free to ask me. Email me, and I'll be more than happy to go over it in class. Other than that, have a great day.